Hello and welcome to another episode of Django Chat, a weekly podcast on the Django Web Framework. I'm Will Vincent, joined by Carlton Gibson. Hi, Carlton.
Hello, Will.
And this week we have two guests from EdX, David Ornsby and Nimisha Astagiri. Welcome, both of you.
Thank you.
Thank you. Happy to be here.
Yeah, we're thrilled to have you. So we connected because we met at the Django Boston meetup, and EdX is both one of the largest educational sites in the world and I believe has used Django from the beginning. So I wonder, we could talk about, do either of you know why Django originally, and then how has that been? Because you've been through a lot of these changes of Django, Python 2 to 3, and so hopefully we can dive into all of that.
The choice for Django, I think, primarily came out of the choice for Python, because this edX originally started as MITx, which it came out of MIT, and so Python was kind of the default choice, right? Like it's the intro CS course teaches Python. All the Europe interns that are going to work on it know Python. And the fact that the first course was an electrical engineering course means that having NumPy, SciPy, like that sort of set of tools was very convenient. And so, like and so, by the way, these early decisions were made by Piotr Mitros, who created the original prototype for what became EdX Platform, and was the chief scientist for EdX for, 5 or 6 years, for a while.
But what was the timing? Because I believe this goes back quite a ways, right? Before Python was standard at the undergrad level for a lot of places.
This would have been, the first prototype work would have started in, I want to say, October or November of 2011. So sometime around Django 1.3, I guess. And so, Piotr also made the decision for Django, but I mean, once you've gotten it down to Python, then Django was like one of the obvious choices.
And can I just ask, because maybe our listeners don't know, could you just give an overview of what the EdX platform is and does?
Good call.
So, Nisha, you're on there.
Oh, sure. So edX is an online education platform. It was founded by Harvard and MIT, as Dave mentioned, in 2011. We do specialize in higher education courses, with courses and content from one of the best worldwide partners from universities.
And what's the sort of scale that y'all are at right now? Because it's in terms of, I guess, number of courses and users, because it's in the millions, right? Of users anyways?
Yeah, it's tens of millions of users, thousands of courses. Like probably over 1 million lines of code if you include all the different Python code, if you include the different repos. So yeah, it's at about that level.
And the other thing is that we are an open source platform as well. So one of the great things about edX is we have edX.org, which is our website, but then we provide our source code to the community. And the Open edX community has thousands of instances of our source code where they are providing courses for regional content as well as even national platforms.
Wow. Yeah, we'll link to those in the show notes. So one issue is, since you started on 1.3, is migrating from Python 2 to 3. Is that something that has happened, is going to happen? How do you think about doing that at such a large site, either one of you? Everyone's dealing with this right now, by the way. I'm not.
It's something that's still in progress. We are hopefully weeks away from getting it. There have been a number of efforts that we've done to try to bridge that. One is the what is it called? We have anchor tickets, which are basically because so much of the Python 2 to 3 conversion is, you can run the tooling for it, and you just kind of have to sanity check that, it's doing the right thing. And like 90% of the time it is, but then, so there was a very conscious effort to be able to try to leverage our community better and try to give them like really small incremental tasks that don't require you to know the full stack in order to help. And so that effort, that Jeremy Bowman sort of really helped push that through. And we did get a lot of contributions, but like And right now, I think Fanil and company and some other folks are sort of driving the last bit. Like once it's working enough so that the tests are running on both environments, like it's been this weeks of just find the breaking thing, watch 300 more tests pass, find the next breaking thing, and then it's interesting because there's the easy part, well, relatively easy, which is just...
Well, there's the strings, right? And then there's the
Right.
like code sniffs on previous stuff, and then there's the real stuff.
Yeah. There's like rounding behavior is a little bit different. And, if we were to change how grade rounding worked anywhere in the stack, there would be consequences.
And then even in terms of backward compatibility, if we, chose to UTF-8 encode the wrong way or whatnot, it's possible that our hash values are not the same as before, and then we might have run into, backward compatibility issues once we actually launch this in production. Yeah, and also just to give an idea, like in our code base, we do have a monolith with close to 1 million lines of code, depending on which code you count. But then we also have a few like satellite microservices that run around our monolith, and so each service needed to be upgraded. And as Dave mentioned, like there was an effort to try to do some of this initially with the community, but because we're running against a deadline, we've actually taken a lot of this resourcing in-house to try to make this happen. So, and there are definitely some things that we could do in terms of like regex replacement, in the strings. There's definitely, just converting, because response.content, now is being returned as bytes. Just there were a lot of code that just said assert in our test code and searching for, within response.content. So replacing that to be assert contains or assert not contains, doing that in one bulk, regex replacement in your ID and whatnot, that definitely helps, get us a long way. But there's a lot of these intricacies that we find as we are going through. We're like, okay, what's the right way of making this change? And then are there any principles that we can follow? For instance, doing the conversion from bytes or conversion from strings to bytes, can that be closest to the perimeter, right? So, throughout our code base, as things are being passed, right, from one method to another and whatnot, pass them as strings as they were before, because that's, that's what the business logic is. But then only when you need to serialize it, let's say persisting in a CSV or sending it over the wire or things like that, that's when you actually then do the conversion. Because one of the concerns that I've always had with some of the Python 3 upgrade was I felt there was so much, I wanted to minimize the amount of code that has to do with strings, so that the business logic continues to stream back at you, right? You don't want your code to be, you want your code to be as readable as possible. You want the business logic to be the one that's screaming back. You don't want to get too caught up on, okay, what's happening in the details with the string conversions. So the more that we could try to keep that logic separated, the better. So that was one of the few principles that I wanted to see, make sure that happened during this conversion.
Well, it does seem that's the hierarchy of any conversion from 2 to 3, where you start off with strings, and those are pretty easy, and then you get to the asserts, and that's relatively easy, but takes a lot of time, and then it gets real with all these other issues. Well, and on business logic, so this is actually, I wanted to highlight this. We talked about this, last 2 weeks ago at Django Boston, because you had a really interesting take on where to put the business logic, because this is a question that Carlton and I get. And for a lot of people, once you get to a decent sized Django project, it's hard to cram it into the models or the managers or the views.
Yes, and Dave and I have, with other architects here at EdX, definitely have gone back and forth on this. And so there's, to step back a little bit, like the reason why we're driving for this, right, is we're trying to scale development of our platform. And over time, it's definitely grown organically in terms of the code that's there and whatnot. But now, in order to allow our code base to be approachable by new developers as well as existing developers, and for us to continue to maintain it, how can we do that in a way that, once again, it's easier to understand what the business logic is? And so we actually had a book club here with, Dave was participating in, and others here as well, for domain-driven design. And domain-driven design, right, really talks about being very focused on what is the domain that you are building for, and having those concepts and having the bounded contexts and those boundaries being explicit. So using that as a mindset, we were thinking, okay, well, given that we have a monoliths don't necessarily always have to be split into separate services. Can you still have great abstractions in place while you're in the monolith? And then if we choose to extract them as a secondary step for other reasons, that's definitely a thing that can still happen. However, even within the monolith, what are those bounded contexts? How do we make our code base such that it's understandable of what those interactions are? Otherwise, there's a lot of tight coupling, and it's really hard to understand. So yeah, I can go. So Dave, you want to add anything to that?
Well, I guess one of the other things that I would add is that EdX Platform started as an application, right? Like it started as an LMS and Studio set up for a particular set of courses on edX.org. And it was made into, an open source project, and it was always intended to be that, but as a sort of, the name is, the name is EdX Platform, right? The idea is people are supposed to be able to build extensions on top of it. And so, which a lot of times you have a much stronger need for these like kind of internal APIs between the apps, because, you might want to take EdX Platform, but you want to add your own thing that accesses enrollment data, for instance, or like because you have your particular special feature that you're kind of adding onto the side of it. Yeah. So and having a sort of strong abstraction layer that you can a sort of stable API interface within the application would be very, very helpful for that. And we've tried to provide that in various places, but it's a hard problem in a lot of senses. Like there are a lot of things that if you try to go into these sort of if you try to move your logic outside of the models, like you cut against the grain of Django in a bunch of ways, right? Like, where you're going to do your validation, if you want to have the same set of business logic that powers like, a REST framework like Django, a REST framework and your views there. But you also want to have not like repeat yourself for like internal APIs. Like, where does that logic go? Like your validation's in the serializer here, but are you going to call the serializer explicitly from your in-process APIs? And you want to pass back query sets, probably in case people want to modify them, because it's often like, hey, get me the these enrollments plus this data that I've keyed off of enrollments because I've added my own table here. Like, how do you do that in a performant way that doesn't encourage everyone to do like n+1 queries? So it's just there's all these parts where you try to it's been challenging for us to do.
And yeah, sorry, go ahead.
Go on, I was going to say, and then to scale up to from a single application all the way up to like 1 million lines of code, there must have been teething points and
yes,
difficult areas. But then the goal, I guess the question would be, do you think at 1 million lines of codes that the general structure is still comprehensible?
Right. No, so you would this is why it's with at that scale of the code base, it's more important, I believe, to be able to understand the historical traces, because unless if we do put a lot of resources to make everything consistent, you will see a heterogeneous code base, right? With some that haven't yet been updated to the latest direction, and some that are still a couple of years behind in mindset and so forth. So we do have this concept of architectural decision records. Definitely, this was also inspired by Michael Nygaard, who and ThoughtWorks had promoted this as well. But architecture decision records are very lightweight documentation. It's immutable documentation records on a decision that you've made.
And that goes into the docs itself.
It goes into the code base, exactly, in a separate decisions directory. And you have a context, the decisions, and the consequences in each ADR. And so for instance, what the directory structure should be of our monolith code base, or that could be an ADR. And then this way people know when exactly that was decided. And then if they do see code that's not yet up to date, they can realize, okay, that was written earlier. And if I'm now going to be working on that part of the code base, let me bring it up to the latest, code standard. So, but yeah, so in terms of maintenance of a large code base, we need to, develop processes such as this to just sort of keep everyone up to date on, because you're going to see broken windows everywhere. So which is the right window to follow and which ones are broken.
So I really like that idea of the architectural decision record. It's like leaving breadcrumbs, saying, look, here's the path.
Yep. And one thing that we also found, going back to where the business logic should be kept, I mean, we were thinking about Django, and initially Dave was a founding architect here. So Dave knows a lot about the initial war stories and how that happened. I joined about 5.5 years ago. So by then, some of the architectural decisions were already made, and there was a lot of organically made changes. So it's actually a great partnership, I believe, because I'm able to have a little bit more fresher eyes, and Dave brings a lot more historical context. But when I approached a code base, I saw a lot of divisions by technical concerns, and this is a thing about Django's out of the box, right? When you're thinking about views and models and urls.py, and they are, in my mind, they're very much technical concerns of, as an engineer, how to think about how to construct something. But if you want to figure out what are the business concerns, what is it that this app is actually trying to do, you don't see that right away when you see these files. Everyone's, it's just models and URLs and views or whatever. So I think, having a way to make that come across much better is what we're looking towards. And then one great example of where this applies is right now, when we're now moving towards a different technology stack base, when we're thinking about moving our front end logic to be in React micro front ends, right? So now whatever business logic happened to be within views.py, or even in a template, or it shouldn't have been the template in the first place, but anyway, some of our code was. So some of those things were in models.py and views.py and whatnot. So how do we, if we had better abstractions in place, it would have been easier for us to do this replatforming effort. And so I think from the get-go, if we could start our Django projects and apps in a way that it's clear where the business logic is, and let the web framework be a detail. And this is what I'm really talking, echoing Uncle Bob here, but the web is a detail, whether it's exposing via REST API is a detail, whether it's being exposed via channels and eventing models, that's also a detail, but the business logic can stay more stable and more core to the app. So that's how I've been thinking about it, and I think Dave's bringing in the perspective also about the scalability and performance impact, right? So if you do have these great, nice abstractions, Nimisha, well, what are we going to do about those queries and the scalability of making sure that when we're not always translating to APIs, when we actually, if we do need to go directly to the models, we can in order to be performant.
I mean, I guess a couple of things I do want to add to that is just one, Nimisha has been at EdX for 5.5, 6 years, the last couple of which she's been chief architect. So she's got plenty of context. I do have some of the old stories. But another thing is that to be clear here, a lot of the early work on EdX Platform, what became EdX Platform, was not very intentional in a lot of cases, right? You take a group of people, most of us had done Python work before. Some of us hadn't. You can actually tell parts of Studio that are written in kind of a Java accent. But we had never done Django. We'd never done large Django. And while Django docs are great for many things and starting out, there was not as much guidance for here's how you build this enormous application, or the foundations of this enormous application or project that that's going to grow to this size. And even if there were, we probably wouldn't have had time to read it because we were in frantic scramble mode. Those entire months are this hazy, sleep-deprived thing that I just so certainly like things were put together very quickly, and I think it's and now we are trying to address some of those things, but you can. But as Nimisha said, like it represents different generations of code and philosophy and expertise and understanding, frankly, of the of Django itself. And so like I can look at a piece of code completely out of context and tell you approximately what year it was written in because
Oh, wow.
just because like of the idioms that like shift over time.
Right. Well, there's also been, I mean, Nimisha, what you were saying about React and the logic from views to the front end. I mean, there's also been that shift in the last 4 or 5 years where, I mean, state in general and logic has moved to the front end. So I don't see how you could have architected for that 5 years ago because, I mean, was it 2013 when React came out, something like that? I mean, that's also just a case of being flexible. And I liked your idea of just having the Django piece, the architecture be as kind of simple as it is so that you can go back and forth as the web changes with how to do state and how to show things. I mean, who knows if that's going to switch back.
Right. And so for us, so what we started prototyping and assessing, and hopefully will solidify into a stronger best practice, but is to actually have a separate module. Right now we're calling it API.py, but essentially it's basically the domain logic.py, where your business logic is. And then the views.py file within a Django app would, consume the functions or, classes that are within those API.py files. And that layer, that domain, let's just call it domain logic.py, that layer domain logic.py then is also an abstraction above your models.py. And other apps that may exist in your Django project, they cannot go directly to your models. They won't access your views or anything else directly, but they would go through an interface right above your domain logic.py. So that's how we're thinking about it. And so this way, if we want to then have Django signals or Django channels integration or some other eventing, if we want to have a Kafka layer later, and these are all ways of communicating out. REST APIs are just one way of communicating out, right? And so that's why views.py then becomes much thinner in that views.py would be more about its responsibility would be more around the authentication layer, like other things that you might want to do, like response HTTP, converting things to proper HTTP response codes and formats and things like that. So that's what that it becomes. It has this very separation of concern from where the business logic is, and models.py's separation, concern its responsibility would be more around the data. And so that's where I'm thinking we're going to try some of our Django apps and trying to implement it in that way. And we're hoping that will then allow us to evolve as the web evolves and as all of our industry evolves. So yes, but you're completely right that there are going to be things that we cannot anticipate. So we'll always need to figure out how to refactor as we go. But like currently that's one way that we're thinking about it.
Carlton, how does that ring for you? Because I was so struck by this conversation we had right before DjangoCon that at DjangoCon, basically the conversation I had with everyone was, where do you put the logic? Where do you put the logic? And folks at really large sites, and it's basically always somewhere else. They call it something else, but it's basically sort of somewhat abstract it from the traditional Django hierarchy. But Carlton, what were you going to say?
Right. So the sort of basic, to much simpler Django example is, let's say you have your business logic, your model validation in your save method, right? You got fine, okay. So, but then what happens? You've got a model form on top of that, and then your view validates the model form. And it says, yeah, this is valid data. And then so instead of returning a 400 saying, hey, this is a bad response, this is a bad request, you've got invalid data, it says, no, this is okay, let's go to save. And then you end up raising an error at the save point, which turns into a 500. That's a server error, right? So you don't want your validation logic in save. I mean, you might want to use it in save, but you also want it available to your form or to your serializer or wherever, so the view can use it so to error earlier and say to the user, hey, what you've given me isn't correct. Can you try again?
Yeah, and I think that's one thing that we also keep running into. And honestly, I'm not completely happy with the sort of trade-offs, even where we're landing. It's just that it feels like you're fighting the framework, right? In a lot of ways, like this is not like the primitive pieces that you're given don't plug in, like don't connect to each other in quite the way you want to make this sort of abstraction work. And you can do it, but on either you can get kind of clunky code and or duplicated code and kind of repeat the validation call like somewhere else explicitly. So yeah, I don't know. One of the big issues that we find on passing models around, for instance, and sort of not having that layer, is that like one. Uh, those things can change, right? Like, we can add stuff to it or whatever. Too, it's like the model passing around models is like this huge implicit interface, right? That you're just kind of just throwing around everywhere, because anyone can say, "Hey, I've got this. Now let me like just grab that class, do a query, and sort by this unindexed field on the field that on the table that has billions of items in it." And like, great, like, and even scarier, it's like maybe that's fine on your machine, that's fine for your system, because your system, you've got two classes and 50 students, and hey, like it works okay. And then you bring it over and you try to merge it upstream, and it's like, no, like this is
Yeah, no, as you go scale up, you need to have more strict rules.
So, and sort of having an explicit layer where we say, like, these are the things you're allowed to call, and these are the things that we can make some kind of performance guarantees around, is really important for us.
And also, to clarify, I mean, there's definitely a maturity model, right? Like, I think where we are arriving is because of the scale that we are at.
Exactly.
For a company that's starting up fresh and new, and with Django, there's so many great things that Django comes out of the box, and actually its defaults are probably good enough for what you need at that time. But I think depending then as you scale, perhaps by users, by developers or whatnot, then you'll have different concerns and different requirements. So for us, for instance, like even this, what we talked about, even for edX at scale, we may not apply this design pattern that we're talking about, like domain logic.py, whatever, to the entire code base, right? I mean, this might be more for, in domain-driven design, they have these terms called core, supporting, and generic. And core is the one that's more of your core value proposition. It has more of your domain concepts. And so at that layer within your core, you might want to have this way and this design pattern. But the things that are perhaps more volatile and more in the periphery, and you do want to change those more quickly and experiment, you're going to just use DRF right off the back and use the serializers and models.py directly. I mean, fine, that's quick. You're trying to, but then if after some time, after a couple of years or months, you realize, oh no, this is a great core concept, then you might want to figure out how to stabilize it more.
Yeah.
So there's definitely a maturity model of the company, of the code base, and then even of a feature.
But also the return on investment. There's no point doing this kind of super engineered high scale thing for a proof of concept. You do it proof of concept, test the concept, does it work? Then we'll put the extra resources in.
And even for us, like our monolith, the way that we're going about and thinking about it is, are there parts of the monolith that are core to the business and core to the platform, and other things that are more extensions, can we build them as plugins? And one thing that edX has developed, and we'd love to contribute back to actually the Django community once we extract it out of the monolith, because right now it's still within it, but there's something that we're calling Django app plugins. And it's built on Python's on stevedore technology that will allow one to basically import their own extensions or plugins to a monolith. The monolith provides some interface, perhaps, but the plugin, its own view, its own URLs.py, and even installing it, all of those things can be automatically detected via stevedore. So anyway, it's a great technology. We found it to be very valuable. Our open source community really appreciates it, because if they need to make a change or want to add something, they don't need to fork the entire monolith. They can just create their own plugin and have it automatically be detected by the monolith. So it very much goes with the solid design principles with dependency inversion and things like that. So anyway, that's where is also an idea, this concept of what's core and what's not core, making that more explicit, and the things that are not core, how can we incorporate them with appropriate bounded contexts and boundaries.
Yeah, and this goes back to what David was saying about giving people a set of APIs they're allowed to call that are safe, right?
Well, one thing I wanted to go over is feature toggles, right? 'Cause I believe you use Django waffles now, because this is another, again, I was having this at DjangoCon with so many people. When you're at scale, rolling out new features, you don't always want to just turn it on. So I guess what did you do before Django Waffle, and how do you think about turning things on given the size of your community?
Dave, you want me to take this? Or
Yeah, you wrote that OEP, I think. So. I'm sorry. By the way, OEP is our sort of proposal process. So that we have architecture decision records that are specific to a given repo. They're kind of local decisions by the team on their particular, like this repo. But if you have something that affects that has implications across all repos, like for org-wide engineering, then we have the OpenEdX proposal process where we have sort of more general guidelines. And Namisha was the one who wrote up the one on sort of feature toggles and such. So.
Okay. Well, it's like Django has its depths. I mean, it's a very similar.
And OEPs were so Kale at EdX, like he came up, I think, with that term, but and this process where yes, it was inspired by PEP. So we have so we have OEP 1, OEP 2, whatever, and it's and so this is Open EdX proposals, similar to Python enhancement proposals. But yeah, so there's one on feature toggles, and definitely the reason we decided we needed to have some good guidelines and best practices for it is because we do when you're now we're talking about scaling and even the deployment of features, right? And we want to be able to allow teams to try features and whatnot in a way that it is more controllable. And we want to decouple deployment from or enablement of a feature from deployment of the code. So this way teams have their own autonomy on when exactly they enable a feature toggle and how it is rolled out to the user base. Perhaps they want to have it in beta testing and then eventually roll it out to a larger user base and so forth. So anyway, we can share the OEP in the notes if you want of the podcast. But,
yeah, that'd be great.
It goes through a bunch of different like use cases. So like I said, beta testing is one. Some of the other ones might just be that we want to, for operational reasons, we want to just roll out gradually in case we are concerned there might be a performance issue or scalability issue or even functional issues and whatnot. And so it allows a lot more control over that. And the thing about this, though, is this, like feature toggles are great and it gives you that control, but then also increases the permutations in your code base.
Yeah, exactly.
Which set of permutations are your tests actually going to cover? And so there's this also process of how do we then make sure that feature toggles that were created and all of those code branches are then deleted once they are no longer needed.
Yeah, exactly. The cleanup is always the hard part.
Yes. And so making teams accountable and reminding them of that. And so this OEP covers a little bit of that process as well, and allowing us to have a tool and a reporting mechanism for understanding exactly when was the feature toggle created, when is the expiration time for it, what was the use case for it, and so forth. So that allows us to then monitor those toggles. And yes, as Will, as you said, we are using Django waffles. Django waffles are great. It allows us to specify whether they're on or off, and then also which subset of users we want to turn it on for, and things like that.
Yeah, it does seem to be the default that I can tell anecdotally that companies are using for this right now.
Yeah.
Well, so another thing we've talked about, I wanted to highlight. So Django celery usage. And this is particularly relevant because at DjangoCon, there's a lot of talk around async starting to be rolled out. And so both how you use Django Celery, and I guess the huge question is if and when Django is fully async, do you see any use cases at edX, or is it more of a side thing? Because that's like the two-parter kind of for a lot of folks. Like, do I actually need it when Celery and tasks, and queues work pretty well? So that's a lot of questions. Take whatever you want to answer.
Yeah, I'll start with a few principles and design concepts that I have, and then Dave can fill a little more of the details. That sounds good. Okay, so I mean, for us, because when we're thinking about running edX in scale, right? We want to keep the response time back to the users as within 1 to 2 seconds. And if there are going to be some tasks or some requests that are going to take longer, either because we need to recompute your grades or we need to, do some extra work in the background and whatnot, it's very important for us to separate those into an asynchronous task. And one of the things that we found was that being intentional about perhaps even separating our reads from our writes is very valuable. And so when someone is, so basically don't do too many side effects and don't do too many costly operations within a request, especially if it's a user-facing request and the user wants to respond quickly. And so you need to be able to put some task into a asynchronous operation. And so Django Celery was definitely one that is a technology that we've used. And initially we were doing it on RabbitMQ, then we converted to Redis for scalability reasons and other reasons. But that's definitely has been a way for us to scale out our infrastructure. I would love though to move towards another model, because one of the downsides with Celery is that as the task that call, basically it's not a fully pub sub model. So you do need to, if you want to be able to have the Celery task run on a separate service, you do need to know what, it's not very easy to have an API that is more like the subscriber needs to know what the publisher's API and vice versa, right? You know what I mean? Like you're too tightly coupled.
Well, in Celery, you import your entire Django project, right? So you have to import the monolith into the Celery instance to run the queue. And it's like, it would be nice if tasks could be sort of separate, if they didn't have to know.
Exactly. And so, anyway, so that's where I would like to lead to eventually. And I was thinking about more of an eventing architecture, but maybe there's something else. And I need to learn more about async and what it provides. And there might be some things out of the box now once we upgrade to Django 2 in a couple of months. But yeah.
Well, Django 3 is when it starts to get real. And even then, it's so 3.0 has ASCII server. And then the plan, I believe, Carlton, is 3.1 will start with views and then ORM thereafter.
And more stuff thereafter.
We tend to hug the long-term support releases.
Don't get Carlton started on this. Yep.
Yeah, well, because because
most people do.
Yeah, but because also we need something hopefully stable. Like when we put out a version of a release of OpenEdX for people to use, because we do have sort of we named them after trees. But we put out Ironwood, and universities that use it are not going to upgrade until like maybe the next the following summer or something when the school's not in session, and so it's. So yeah, we're not going to see async on the big repos. So the smaller repos tend to go up faster because there's just less sort of inertia to move, and also fewer groups run like the e-commerce service that we have as opposed to the everyone runs EdX Platform because it's where the LMS and the authoring environment is.
Right.
So yeah. In terms of the async though, there are features I would love to play with.
Yeah, like what?
I mean, channels is great. I played around with version 1 of channels before it became. I can't play around with version 2 on the EdX Platform because
Well, Carlton's in charge of maintaining channels now.
Okay, that's no, it's really cool stuff. And frankly, there's a lot of stuff around like WebSockets and such that we love to use. Having async support for like service calls that are not blocking can make better use of better use of resources is great. Although I think EdX Platform is a bit unusual for Django project in that a lot of our performance issues or performance challenges were actually CPU and cache related.
Really? Oh,
Yeah, I know.
huh.
That's so there. So okay.
So what are you
so
processing? Like what's because
okay,
because as we've
courseware.
been talking, I've imagined that you've got database scaling issues, you've got a lot of content, you've got videos, you've got course content, you've got other loading sites, loading pages, but where are the calculation issues? That's kind of interesting.
Okay, so this is this is yay history stuff. So when edX started, right? We were like again like imagine. So it started with a single course that was being offered to both MIT students and as a MOOC version that ran sort of 2 weeks behind the MIT cohort, and like okay, when Coursera, if like those early days, if like a Coursera or Udacity, they can say, oh, we're going to push back the start of this course by 2 weeks because whatever to help iron out, and they're non-paying students are like, okay, that's cool, whatever. You don't tell MIT you have to delay the semester for 2 weeks, right? Like that's just not gonna happen. So a lot of things like those things were like really like too sort of very quickly put together. And one of the things that was put together was that the course format in those early days, the course teams, it was XML. It was like a giant XML file. In fact, it was a giant XML file that was a Mako template. And so the entire like definition of what the course is, all the sequences, all the problems, were this big file that Django read on that the project read on startup. And it's really easy to like create a set of objects like this very quickly. And that's fine for the prototype, but obviously, like the prototype days are over, and we are in the world now where everything's in databases, like you would expect. But a lot of the sort of access patterns, if you look in sort of those early days, like when you're trying to prototype something, you're going for maximum power with minimum code, and you can create. It is easier to create really powerful interfaces than it is to create performant data models, right? So
Yes.
like as an example, like if you look at the grading code, like the original grading code for EdX Platform was basically, okay, here's my tree of content of everything in the course. I'm going to like crawl through, check, go through the whole tree by checking my children. And for each node that can be graded as a gradable thing, like a problem, I'm going to ask that pluggable interface, hey, how many points are you worth? And how many points did the student earn based on their like current state of your problem? Because we have this notion of like X modules back then, and like videos were X modules, problems were X modules, everything. So you had some common set of interfaces you could ask. And that gave you a great deal of flexibility in terms of power. But at the same time, how long does it take to show the progress page when you have to ask this question of every node in the course? And the answer is you have no idea, right? Because you created this interface where like it's like max score and get score, whatever, and you've pushed off having to think about the data model. But in return for that, you've lost all ability to like reason about the performance of the system, right? So we had X modules that started sandbox processes like in Python and did RPC call to sort of get information because you don't want untrusted code to be running. We had ones that would like parse their internal XML, and depending on how many response types you had inside would change their score accordingly. We had ones that would make HTTP calls to another system entirely to get back like what the latest score for that person was, because the first version of peer grading happened on like a different service. And so like if you wanted to make an X module that would return you a different max possible grade for usernames starting with C on Tuesday afternoons, like there's nothing in the contract that explicitly forbids that. And so
I'm seeing a theme here with the architecture.
Yeah, exactly, right? But once you sort of have that out there, Like, that's fine for the prototype and for an exercise. That's not cool when you have millions of users and you're trying to run a course at scale. And so you find yourself trying to claw that back in a bunch of different ways. And so eventually what happens is you sort of have this sort of shift that goes from your courseware being these like smart objects that you can just make requests for and leave it to them to figure out how to implement it. And you sort of shift that relationship to be, okay, I'm going to have a grading system. The grading system has a data model. I know that the grading system, I can query it. I can ask for things like, what is this student's grade in the course, and get a quick reply. And then I'm going to make those the X modules and X blocks, the courseware, like individual leaf nodes, they're going to push data into that data model so that I can query that efficiently, right? So you have this kind of like shift, and that applies to a bunch of things. We have to do that for grading. We're doing that for more scheduling related things. But it's hard to do that in a sort of backwards compatible way because we have a lot of course teams expended a lot of effort into a lot of like course content. And so I think one of the things that Namisha was sort of pointing out was one of the ways we do this is to kind of shift it, like use async methods like celery tasks. Not async as in the Python async, but use celery tasks in order to kind of shift the burden of processing. So for instance, right now, what happens is that there is a grading system and it will hold your scores like whenever they change. But there's a set of very complicated permissions calculations that came about because, hey, we have this whole thing loaded in memory already, right, guys, right, yeah. And so now what we do is when you change a score, those crazy computations still happen, but they happen in a celery task that runs, and then it puts your like calculated score into this grading system that has a data model that you can actually make guarantees about. And so that's been sort of our bridge in a lot of ways to take things from this like the smart object world to the like discrete services world. But that's the reason why we're CPU bound in so many things.
Can I just ask, if I was writing a new module, a new plugin, I'd just go straight to the new data store. I wouldn't go via the old mechanism. Is that?
Yeah, I mean, probably.
Right, I don't know.
Definitely. I mean, there's a grade system now, and if you want to ask questions about a student's grade, yeah, you would go to the new thing. You wouldn't want to mess in that one.
Namisha, you were going to say?
Yeah, I was just going to say that one of the design principles that, when we're thinking about when we implemented the grading system, and we're talking about persistent grades before grades were computed on the fly, and now we're able to read them from the database. But in order to make that happen, because we had so much flexibility with those X modules and X blocks and what they could do, and giving us data in the runtime and all that stuff, we were inspired by, it's like the reverse ETL. With ETL, basically with ETL, you're reading the data, then you're transforming it, and then you're writing it into a new form. It's reverse in the sense that basically we allowed these plugins and these Xblocks, right, to basically give us a lot of that content, and they were able to then write and push that into a form that then they were able to then transform however they want to for read optimizations. So basically, that's where that separation of reads versus writes come in, where like we want to have very fast read optimization views of this data, and do it so we implemented this very simple interface where basically allowing anyone to collect the data and then allowing anyone to transform the data. And then we automatically look through all of the transformers that are registered in our system, run them through, sort of like an ETL type of thing there, except it's LTE in that, it's allowing people to write. And then when it comes to responding to the user, we're able to do that very quickly because it's already transformed for read optimization, and then the response times are now once again improved. So it's tricks like this that have allowed us to figure out how can we take what we had legacy-wise. They were a lot more generic interfaces, we're going to be more intentional going forward with what our APIs and interfaces are, but we still needed to support the old. So how do we do that in a way that's performant, but now with optimizations in mind?
And actually, there's one other thing I want to add. In defense of the people who made that system originally, like it is really powerful, right? Like there are if you are in a situation where you don't know what the interface really is for like what you should and shouldn't allow for grading, and also where there are bugs all over the place, right? We're building the platform as the first course is running on it, and this bug, like you detect this bug is misscoring someone, or like is interpreting the score wrong, then if you store it in a persistent state, then okay, you have tasks to like regrade them and restore and modify their stores and whatever. If it's always dynamically computed on the fly, then like just reload the progress page. Boom, where your score is fixed. And so it was one of those things where like and even the sort of query anything, like one of the sort of painful things about moving from like query the smart object to like separate systems is that you do lose some power, right? Like the very original version of the prototype that we had A/B tests running in a totally hacky, crazy way, but they were running. And it took us years to get that functionality back in a sort of more like predictable and performant way, just because like it's so that there were trade-offs, and I definitely like I have suffered from the grading system more than most. So has Nimisha, but and so definitely I'm not going to say that is the way you should architect it. But I guess I feel like it's important to note that there are trade-offs, especially for something that as young and quick as we were doing back then.
When you're prototyping, to just write a Python class and keep everything in memory is, pickle it if you have to. If you want, that's a great development environment, and that's a great way of finding out what your requirements are when people can't specify them for you. You can say, what does your grading system involve? And it's like, well, A to F? No, it's loads more than that. What does it actually involve? Well, we don't know. So, well, let's build something, let you use it, and then when we've exposed what the actual requirements are, then we can build something which scales up.
As we wrap up, one thing, if we can, I'd love to talk about the automated discovery of CSRF issues, because this is something, Nimisha, you and I had briefly talked about Django Boston. You'd mentioned just generally there was a number of security things that edX had come up with that to help Django, but weren't part of Django core.
Yes. So, I mean, security is definitely very important to us. I think Django's definitely improved, at least from the last 5 years that I've seen, like over time in terms of having more secure defaults. I think for us, we do have a security working group within edX that triages issues that come in. And so over time, there have been some issues that are more prevalent than others. The automated discovery of CSRF issues, that was something that I had written a while back. And sorry, I'm trying to just context switch what that was in exactly. But I think what that was basically side effecting GET requests, right? Whenever someone makes a GET request, we want to make sure that there are no modifications to a model or, to any data, right, in your system. So
on a GET request?
Yeah, no. So in courseware, this actually like was the case for various student tracking things.
Okay.
Yes, and so and courseware, yes, might have a legitimate issue that when it did that way, but we found, so basically I had created this middleware. It was a Django middleware, I believe, and whenever there was it detected that there was a GET request being made, and then what it did was actually I think it used Django signals to track any post-save model changes. And so it was able to detect if any Django model changed whenever a GET request was made, as opposed to post request, right? So and that then basically we reported this, and then you would be able to realize that this is a potential CSRF issue that needs to be fixed. And I think there was other things too that I detected. I may have detected if there were Django celery tasks that was also being initiated whenever a GET request was made. So anything that could have potentially had a side effecting, a side effect that could have resulted. So So that's something that we had created. I think what happened was we found a few CSRF issues within our system, and so we had then been fixing them over time. And so at some point we wanted to make it a public application others could also use, but we haven't gotten around to that yet. So we'd love to be able to contribute that as well.
There's also like Robert's CSRF. Wasn't there like template level CSRF stuff that runs in our Jenkins builds now?
Yeah, those are XSS.
I'm sorry.
Robert has implemented an XSS linter as well, so he's able to detect if there's any XSS issues in Django templates. And maybe other things as well. Yeah.
So Carlton, would Django be interested in these things?
Yeah, I mean, quite probably, yeah. I mean, if they're extracted nice and small and easy to implement, yeah. I mean, just going back to the CSRF example, that's a great use of signals, right? So people use signals as a way of decoupling their application, but they can get overused and they can lead to hard to understand and hard to follow code. So the sort of maxim I always use is, do you know at runtime who the receiver of this signal is going to be, who's going to act on this signal? And if you do, don't use a signal. But of course, when you're monitoring, are there any saves across any models in this request? You don't know who's going to be sending it, so you don't. It's perfect case for signals. It's a lovely example.
Right. No, signals can be very powerful, and there are actually good use cases for it. So this is definitely one. Another one I will say is that when we're thinking about the monolith and the core, and then we have these Django app plugins, because there too we don't know who the recipient is, and it's not core to our platform. We'd actually prefer to use Django signals as a way of communicating that out. But then to our earlier point, that then becomes an intentional interface.
Yeah, and you have to document that and provide guarantees and
reported and all that stuff. But Django signals does allow asynchronous. It allows decoupling, of your components. And so, but yeah, I agree with you. That's a good rule of thumb. If you don't know the recipient, then it definitely makes sense. I mean, this is a possible interface that you could support.
Yeah.
I mean, I'm sure we could keep talking. I know we're kind of run out of time. Thank you so much for sharing the realities of a large scale code base, because this is how it is for everyone. There's always the trade-off between prototype and legacy. And, I guess the thing when beginners ask me sometimes about these questions, I say it's an honor to be where you all are at. As frustrating as it is, it's like these are the problems you want to have, that you're at scale and you're keeping up to date with Django. So it's fascinating to hear kind of under the hood, how it's all working and how you're thinking about it. And we'll link in the show notes to a number of these, especially the OEP. That would be great.
Yeah, really super interesting.
So again, thank you, David. Thank you, Nimisha.
Yes, thank you both.
And for those listening, we're at djangochat.com, chat Django on Twitter, and we'll see you all next time. Bye-bye.
Join us next time. Bye-bye.